And finally, we come to acceleration. If you're moving at a constant velocity, your velocity is not changing and the acceleration is zero. So in the middle of each of these intervals, the acceleration is zero. However, when you change your velocity, which could be either changing your speed or changing the direction you're going, there is acceleration. And so in between these, there is some kind of acceleration. So, and we're not going to worry about the magnitude of the acceleration in these graphs. What I'd like you to focus on is the sign. And so there is going to be acceleration at, so I'm going to put time again here, and we're going to draw the graph below, at 1 second. Let me make this in between. At 1 second, you go between these two. When you go between these two, that is going to be at 4 seconds, around there. And then when you go between these two, that's around 7 seconds. And finally, when you stop again, around 9 seconds. So there's going to be some acceleration around those times. If you had a cart, this would be where you have to push the cart, apply a force either in the positive x direction or the negative x direction. Now, the cart is actually not a bad analogy here, because if you remember F equals ma, and so you can think about this. If you were doing a cart, what kind of a force would you need to do to get it going in the negative x direction? Well, you'd have to apply a force in the negative direction, which would be like an acceleration which is less than zero, negative, okay? And now here, you're going to, the cart or you are moving in, running backwards quickly in the minus x direction, and then you go to going backwards less quickly, all right? Now, if you think about how you would slow something down, if you had a cart that was going like this, and you wanted to slow it down, so if going from -3 to -1, you'd have to apply a force this way. And so the acceleration here is positive, which is sometimes confusing because the velocity is negative, but what you're doing is something that's going in a negative velocity and slows down actually has a positive acceleration. Okay. Now at 7 seconds, you go from the negative velocity to positive velocity. You should be happy with that because you are increasing the velocity in the x direction, and so here the acceleration is 0. And finally, you're going forward and you stop. So that's sometimes in cars we call that deceleration, and here the acceleration is negative. So I'm going to draw a smaller graph here just because there's not as much information in it. So here should be acceleration time, and the times when we have acceleration are 1, 4, 7, and 9 seconds. And what I'm going to do is to make sure I get the signs correct. So if I go through here, this is going to be negative, positive, positive, and negative. And again, if you want to think about this as a cart, which way would you have to push the cart to get it to do what you wanted? So to go from a standstill to get moving in the negative direction, you'd have to push the cart this way, which would be negative acceleration. If you want the cart to go the other direction, or to slow down, then you have to kind of put on the brakes, and that would be positive acceleration. Then you want it to really go fast this way, so you're going to push this way, which again would be positive. And then finally, if it's moving this way, to stop it, you have to push like this. That's going to give it negative acceleration. Okay, so this is acceleration versus time.